So what I'm going to talk about or explain is how to predict what's going to come out of a double replacement reaction. I'm going to use the reaction I used today in class, where I took lead nitrate, PbNO3, and dissolved it in water, so it was aqueous, got the aqueous designation. I added to it potassium iodide that I also dissolved in water, so it gets the aqueous. When they went together, I formed lead iodide, PbI2, that turned out to be a solid. And to complete the reaction, I also had potassium nitrate, NO3. And that happened to stay dissolved, aqueous. Now, how did I know all that stuff? How did I know which product was the solid, which stayed in solution? One thing I should do is go back and complete this by balancing the equation, putting a 2 in front of there and a 2 in front of there. But looking at this equation, there's a whole lot of stuff going on. I'm taking two reactants that are on this side and forming two products on this side. I've balanced it, so I know that the mass is constant from the product side to the reactant side, and I know I came up with something new because I saw this yellow stuff form. The yellow formed that I formed today was a yellow precipitate, lead iodide. But how do I know that the yellow was lead? Well, that's what I'm going to show you, because in a double replacement reaction, one of the products has to either be a solid or a gas or possibly water being formed. But I'm going to focus on which one it is that it's going to be the solid. So the way you figure that out is you take a look at a solubility table, a chart like this, all right? And I'm going to draw, I'm going to put in the two reactants again, okay? Just draw them up here. I had the lead nitrate, NO3, twice, and I had the potassium iodide, Ki, that I was reacting together. Now, what's going to happen is, or what did happen, is the lead went over and found the iodide, and the potassium went and found the nitrate. And that's, a pretty simple idea of what happened in this reaction, but I want to know what those two products are. Which one is the solid and which one stays aqueous? Well, what I do is I look at this chart, and I use this chart to tell me. It's kind of like a modified mileage chart. One of the products is going to be lead iodide, okay, right here, PbI2. So I'm going to look up at this chart, and I find lead right down here. So there's lead, and I'm going to follow the lead across until I hit iodide coming down here. So there's the iodide right there. So I'm bringing it right down there. Where they intersect, it has SS, all right? Well, SS on this chart, or I, together, either one of those, mean in the equation they will be considered solids. And you'll get the little S designation in the balanced equation. So that little S goes right here. And the yellow junk that I formed was the potassium iodide, because this chart told me that was the solid that came out of that reaction. Now, the other product over here was, was KNO3. And if I look up KNO3, I don't know what to do, but here's potassium, down here, and nitrate is right here. I drop down to where they intersect. It has an S. Well, an S on the chart, on this chart right here, means it is going to be aqueous in the formula. So AQ goes right there. And as I talked about today, it turns out the potassium, obviously the potassium iodide was aqueous because I had to start off with 2 aqueous solutions, so these are all aqueous. And you can figure out, all right, the potassium was a spectator because it didn't change, the nitrate was a spectator because it didn't change, so the net ionic equation out of this whole thing, the basic net ionic equation, would be Pb plus 2, which was aqueous, dissolved in water, plus an iodide ion, aqueous, dissolved in water. The net ionic equation also has to be balanced, so I would need 2 of those. The product coming out of it was lead iodide. And because the chart told me so, because the chart had an SS, so the chart said that Pb I2 was SS. SS means it's a solid, so in the balanced equation it gets the solid subscript. So anyway, this is the true reaction, or the nuts and bolts of what's going on with the double replacement reaction. You have a cation and an anion finding each other, forming an insoluble salt, and a chemist would describe that as a precipitate and say literally the lead iodide fell out of solution, and that's what it did.